I'd like to take a look at another problem that I'm actually going to do 2 or 3 different ways for you. Once again, I've set it up as f of x equals x over the square root of x. Now, I've got a quotient again, so first thing I'm going to do is apply the quotient rule. Before I can even do that, you'll notice though, I had to take radical x and convert it to a power so that I could use my power rule. Alright, remember again what our quotient rule is. Again, if it's u over v, it'd be v times the derivative of u minus u times the derivative of v all over the square of v. Or if you prefer, low d high minus high d low all over the square of low. Alright, now let's take a look here and apply this to our specific problem. I'll take low, which is the square root of x, d high, the derivative of x is 1, minus high times the derivative of low. Now in this case, I'm going to use this form again. I'll move the 1/2 out in front and subtract 1 from the power, which gives me 1/2 times x to the negative 1/2. Now let's do some basic simplification. To be honest, the first thing that I don't like is I've got this complex fraction. I've got a fraction inside a fraction. Let's take this x to the negative power and move it down to the denominator, where the 2, frankly, is already. That leaves me with just the x in the numerator. In the denominator, I had the 2 before. When I move the x to the negative 1/2 down, it becomes x to the positive 1/2. Radical x times 1, by the way, is simply radical x. Now, let's put this back in radical form. I've got x to the positive 1/2, and that, frankly, is just the square root of x. Once again, I've still got this complex fraction. I don't like it. I want to get rid of it. So I'm going to multiply top of my fraction and the bottom of my fraction both by 2 radical x. Now, in the numerator, notice the 2 radical x times radical x gives me 2x. When I take the 2 radical x times the second term, the 2 radical x's cancel, and I'm left with just negative x. In the denominator, I have a 2, an x, and a radical x, and there's really not much I can do there than write this nicer reordering of those terms. So I just have 2x radical x. In the top, again, I have simply 2x minus x, which gives me just x over 2x radical x. And if I now cancel out my x's, I'm left with 1 over 2 radical x. Now, I hope you noticed at this point that one of the things I could have done back at the very beginning would be to move this x to the 1/2 up to the numerator. Again, you can do this anytime you wish to make the problem easier. In this case, if I move that x up to the top, that term becomes x times x to the negative 1/2. You can try this trick anytime you want in order to turn a quotient rule into a product rule. At this point, instead of a quotient like I originally have, I've now rewritten it as a product. And that rule simply stated, if I have a function that's equal to the function u times the function v, then I can think of that as the derivative of the first times the second minus the second times the derivative of the first. Let's apply that rule to this problem. So I have my first times the derivative of the second. I bring the negative 1/2 down in front, and I subtract 1 from the power, which would give me negative 3/2, plus the second times the derivative of the first, which would give me x to the negative 1/2 times 1. Now let's do some simplification here. Let's take this x to the negative 3/2 and move it to the bottom, where it becomes x to the positive 3/2. Let's also move this x to the negative 1/2 to the bottom, where it becomes x to the positive 1/2. Now let's do some simplification here. You notice that I have an x in the top and an x in the bottom. Taking away one x from the top leaves me with nothing, and when you're literally multiplying and dividing, nothing is 1, of course. So this becomes negative 1. taking 1x from the denominator, if I had 3 halves, taking 1 away leaves me with 1 half. The second fraction I left the way it was. Now let's convert those to radical form. So both cases where I had x to the 1 half, I write those as radical x. Now, to be honest, at this point I'm really done. It's in proper form, it's been converted back to radical form, there's no negative exponents, there's no fractional exponents. This would be good enough on the test. But I want you to notice that I had a slightly different answer here before. What I want to do is show you that both answers are actually equivalent. In this case, let's begin by multiplying both the top and the bottom of this fraction times 2. Doing that gives me a 2 radical x so that I have a common denominator. Of course, 1 times 2 left me with a 2 in the top, and 2 times radical x gave me 2 radical x so that my denominators would be the same. Combining those terms, of course, if I take 2 minus 1, or if you prefer, negative 1 plus 2, leaves me with 1 in the numerator. So once again, you can see that both of these answers are indeed equivalent. I wanted to show you one last thing here. Let's take a look. I'm going to do the problem one last way. Let me first off show you our original function we had before, which was x over radical x, which I've got here on the second paper, I guess. And I rewrote that as x over x to the 1 half. But you'll notice I could reduce this further. I have an x in the top and an x in the bottom. If I subtract my exponents, there's an understood 1 here, minus the half gives me x to the 1 half. Let's go ahead and take the derivative. That means f prime of x would be, take the 1 half, move it down in front, subtract 1 from the power, and gives me this answer. Now again, I've got that fractional, I've got that fraction, I've got that negative power. I don't like negative or fractional power, so let's fix it. I'll first move it into the denominator, where this will become x to the positive 1 half. And finally, merely converting this back to a radical form gives me 2 radical x. Now I'd like you to notice that the first thing I did was the quotient rule. That was the hardest of the 3 methods I've shown you here. I don't ever like to use the quotient rule. I always recommend, or nearly always, merely moving that denominator up to the numerator and making this a product. Now, honestly, it doesn't matter whether you look at it as a quotient rule or a product rule. In either case, I could have simplified. It's always easier to do the algebraic simplification. And in either case, I would prefer, I think you'll find it easier, if you merely reduce and combine your terms algebraically to simply make the function x to the 1 half. This would by far be the easiest way to do it. As always, you can do it any of those 3 ways. Those were all legitimate methods to solve the same problem. You do whatever you think is the easiest way to do a problem on any test problem, and I'll give you credit irregardless.